Hello everyone, myself Dr. Thrimurthulu, Professor in the CSC Department, MLR IT, and subject is Introduction to Artificial Intelligence. This is the fourth video, and now the today's topic is AI agents and models, agent-based model systems. And in these agent model systems, what are the different types of agent models? I will discuss. Then, what are the simple reflex agent model, model based reflex agent model, goal based agent model, utility based agent models? Briefly I will discuss in this video. And the previous class we have discussed with the what is an agent and the agent environment and the agent functions. And related to this topic, there are what are those different types. Artificial intelligence it is the study of agent and its environment mainly. So here AI agents are computer programs that act independently of their surroundings or environments. It captures the environment perceptions, based on that it will act. And AI and agent and automatic task, it will work for the automatic task, interact with the environment and get the perceptions and make helpful for the right decisions. So like what are those examples means here? Robotics, chatbots, smart home devices are common applications of AI agents, like many applications. What are those technologies in this related to, like machine learning, data processing, image processing, pattern recognition, computer vision, natural language processing are the key technologies that enable these agents to work independently. And coming to the, so what are those different type of models? So these are the based on their degree of perceived information, perceived intelligence and the capability, so that they are mainly classified into 5. So one is the simple reflex agent, second one is the model based reflex agent, the third one is the goal based agent, fourth one is utility based agent, the other one is the learning agent. There is the other agents also, they're like multi agents, hierarchical agents. So what is this simple reflex agent? And this simple reflex agent is the very basic model, agent model. In this, on the basis of the current perceptions only, whatever the current perceptions it is giving, based on that, if the condition is matching, then take the action. So based on the only current perception and ignore all the rest of the percept history. Here percept history means what it is that all agents perceived up to date before that. And it is ignoring all those things, and then whatever the environment is there, environment perceptions it is getting through sensors, and whatever the current perception is there, based on that only the action is going on. The action also based on the conditions, only. If the condition is matching, then the action is going on, then the instructions is going to the actuator, then the action is going on the environment. So here see, a condition action rule is it maps the state, the condition to if the condition is true. If the condition is true, then the action is taken. Otherwise, there is no action in these cases. So this agent function only succeeds when the environment is fully observable. And it is not matching it is not supporting fully in partial observable environments, because it is getting, if the infinite loops are there, means it is the taking time, unavoidable things like infinite loops, you have to avoid it for these simple systems. So what are the problems you are getting in simple reflex agents? So very limited, because it is only limited intelligence is there, that the one thing, and no knowledge on perceptual parts, and previous history it is not considering, and a previous state also it is not considering. Usually too big to generate and store generally. So it doesn't have a storage, so that is also problem for these cases. If there occurs any change in the environment, then the collection of rules needs to be updated. Then the rules also you have to change it if any environment is changing dynamically, means here rules you have to change it. That is the one thing. So that what it is, very limited functions, whatever the algorithm like function it is, based on the function it is working. So the simple reflex agent function is it taking the static rules, a set of condition action rules we are mentioning here, and whatever the state is present state, it is taking interpret the input as a present state. It is taking the input from here. Then rule, it is rule match. The rule is if the whatever the rule is, if it is matching, yes means it will execute, otherwise no means it is not. The rule matching is important in this case. Rule, then the action is rule. If the action rule is matched, then action is going on, then return the action, then it is again it is going to the next state. So this is the simple reflex agent system. And what are the strength in these cases? The advantages in these cases means they are very simple, that is the one thing, and easy to implement. And simple reflex agents are fast and efficient also. And coming to the next, these AI agents are suitable for well-defined environments, means fully observable environments only it is useful. So what are the weaknesses in these cases or drawbacks? They have limited adaptability. That is the one thing. They cannot learn from past experience. It doesn't consider the previous history. So that is the problem. They cannot learn. And these agents require only fully observable environment. Fully observable environment. That is those are the weaknesses in these cases. Adaptability, limited adaptability, and it is the fast experience. It is not considering. That's why it doesn't have any experience. And it is only suitable for the fully observable environment. So what are the examples, applications related to this one? So one is the thermostat. So thermostat, what it is, the temperature sensing element. So what it is doing, it senses the room temperature and turns the whether heater is on or not. The predefined temperature is there, based on that whether the heater has to on or off, based on the condition. The temperature below means it has to on the heater, otherwise it doesn't it should not answer on. That is the thing. Otherwise thermostat, it is also useful for the air conditions also. If the temperature, predefined temperature is there, if the temperature is crossing that one, the AC has to on. Like this, the condition is the AC has to on if the temperature exceeds, otherwise it not. So like this, these are the thermostat is the one of the application. Then light sensor in a street lamp, based on the temperature, based on the daylight, the lights, street lights has to on. So it detects the darkness and triggers the lamp to turn on. That is the one thing, light sensor. And vending machines, you select the product, the button already predefined. If you are pressing that button, the particular weight it will pass. So overall, the simple reflex agents provide basic framework for building more complex agents. It is the basic framework for the building more complex agents and serve well in specific controlled environment. Okay, so this is the simple reflex agent system. The other model is the model based reflex agent, little bit advanced as compared to simple reflex. Same thing, same environment is there, and from the environment it is perceiving the information, and the sensor it is sensing that one, it is giving to the agent function. So in this agent function, what the world is like now. So how the current perceptions are, and it has the internal state is there, what kind of state that is, and how the world evolves, how we have to evolve the things, what my action has to do based on the perceptions. So then, so whatever the decision is there based on that those present state, and the how the world evolves based on that, it is taking the decisions. So that is decision, what actions I should do now, that is the questioning. So that action also based on the conditions, if the condition is matching, the action is going on, otherwise the action doesn't. So when the action is the condition is matching, then it is going to the actuator, then actuator to actions are in the environment, like this. So this model based agents handle situations where not everything is directly observable by the sensors. Even partial observable environment also, this model based agent it is working. For instance, simple agents struggle in partially observable environments, as you have discussed in previous model system. So where they cannot see everything, here you can Model based agents, even it works in fully observable and partially observable situation environments also. On the other hand, what it is, model based reflex agents address these limitations by building an internal representation. This is the internal representation is there, the present state like this, internal representation of the environment. The model keeps the track of the world state, how it is the present perceptions, what is the previous perceptions. So the model keeps the track of world state based on the fast sensors reading, fast information how it is. So what is the present based on what kind of actions you have to take it. So whether it is the condition is matching or not, it is checking. If the condition is matching, the actuator will take the actions. So this way, when the agents encounters a new situation, suppose that environment is changed dynamically, new situation is there, it can consult its internal model. This is the internal model. It will consult with that. Then based on that one, it is taking the decisions. So that it is advantage in this new situation. It can adapt. It can consult with the internal model to understand the context, what it is, or what kind of actions you have to take it. The agent can then use the pre-programmed rules along with the model to decide the best course of action. Updating the state requires information. Whatever any updates also in the state, you can update it. So these are the advantages, somewhat advanced model as compared to simple reflex agent model. And here how the world evolves independently from the agent, that also questioning it. And how do agents action affect the world? If you are taking the action, what happens? That also it is questioning itself, and based on that, the decision it is taking. The agent function is, this is the agent function. Okay. So states, it is same state a description of the current world state, what it is state, that is rules here, predefined rules are here mentioning here, rules, the condition rules, a set of condition action rules. Action, the most recent action, initially none. Before that there is no action present, based on that it is taking the action. State, whatever the state, it is continuously updating. What the current is going to the next, then it is continuously, it is pursuing the information from the environment. So that based on the update state, what is the state, what is the action, previous action, what are the percepts, all these it is analyzing. Then rule match, if the rule is matching, the actuator will activate. So the action is through actuators, return the function. This is the model based reflex agents. And what are the advantages or benefits with model based reflex agents? They can handle partially observable environments. That is the one advantage. Even fully and partially observable environments, both the things, it will work. These model based agents are more flexible as compared to simple reflex agents, and they can use the internal model to make predictions about how the environment might react to their actions. That is the one thing. So what are the drawbacks in this system? The drawbacks are, there is an increased level of complexity, somewhat computational level is increasing. So that increased complexity, that is the one thing. The agent's performance relies heavily on the accuracy of its internal model, totally depending on the internal model, how best it is giving the decisions, how best it is analyzing the things. So there is always an issue of limited learning. There is the limited learning is there, the current state and previous state. Based on that only, it is very limited learning only. These are the drawbacks in this system. So what are the examples related to this model? So self-driving cars, one of the best examples. Self-driving car, how it is, the road environment, how it is. The car agent is the car. So based on the sensing information and what is the present state, previous state and the present state of it is, whether you have to move fast or you have to brake the things or you have to accelerate the things, all these things based on the environment, current environment or at the previous state also it is considering. So the self-driving cars is the one of the best example for this case. And vacuum cleaner, the another one is the vacuum cleaner, room cleaning, automatic vacuum cleaner. So more advanced, in this internal map of the room is there. So all the four corners and the coordinates are there. Based on that, it is cleaning the particular whatever the time you are mentioning, in that particular time it is cleaning the room automatically. So robot vacuum cleaner is the another example for this. Chatbots. So with the context awareness for chatbots, so can maintain an internal model of the conversation to provide more relevant responses. It is giving the relevant context based relevant responses it is giving chatbots. So these are the few examples for the model based reflex agents. So notably, model-based reflex agents offer a significant improvement over simple reflex agents as compared to that one. However, these AI agents rely on pre-programmed rules because the condition is matching only, it will work based on the pre-programmed rules and don't exhibit true learning capabilities. It does not learn the actual learning, only present, previous only. So the other one is the third one is the goal-based agents. This is the goal-based AI agents have a specific objective in mind. Specific goal is there. I have to reach that goal. So specific goal in a specific objective in mind. That is nothing but a goal. They actively plan their actions to achieve that goal. Okay, this is the only purely goal based. Same kind of system, same kind of internal state also it is there. It is taking the perceptions environment and what the world it is like now it is questioning, and based on the present previous state and present state what kind of type how we have to that situation, and based on that what it will be like. There is the decision. If I am taking decision like this, what happens? If I am taking decision like this, what happens? Like this, there is the options are there. Then what action I should do now based on the present goal condition where I am. Based on that, how far I am from the goal. Based on that, the what kind of action I have to do it. The action is going on through actuators. Same thing it is. So here see these kind of agents take decisions based on how far they are currently from their goal state. Based on that only the actions are going on. So their every action is intended to reduce the distance from their goal. So whatever the action, how best you have to reduce the distance. That based on that only the action is going on. So this allows the agent a way to choose among the multiple possibilities, selecting the one which reaches a goal state, and there is the what are the various possible ways it is identifying. So which one is the best way to reach the goal. So the knowledge that supports its decision is represented explicitly and can be modified, which makes these agents are more flexible. That means the agents are more flexible as compared to previous one, because dynamically based on the environment conditions, dynamically it is adapting to the new situations. They usually require search and planning. Search and planning is the goal-based agents behavior can easily be changed based on the how far the distance from the goal. Based on that, then what are the advantages goal-based reflex agents? The advantages are they can adapt their behavior depending on the current situation of it is. Based on that, it is adapting immediately. The AI agents function in environment with multiple possible outcomes. It is giving the and multiple possible outcomes. It is questioning if I am taking decision like this, what happens? If I am taking decision like this means what happens? So which one is the best? It is choosing. So that which one is the reach the goal best way. Like that it is based on that it is taking the action. So that is the multiple possible outcomes are there. They have solid reasoning capability because like this reasoning, if I am taking action decision like this means what happens. Like this reasoning also is there. What are the weaknesses in this system? The planning algorithms can be computationally expensive because the expensive computational cost is more. Defining clear goals is crucial for the agent success because how we are defining the goal is important. The clarity is important. If the agent doesn't have a complete information about the environment, its planning might be flawed. It is. So careful the goal how it is, how far you have reached the goal. So like this, the information is important for these cases. So what are the examples goal based reflex agents? The examples are um, robot path planning, robot path finding or robot path planning purpose. A robot might use the goal based approach to plan its path around obstacles to reach the specific location, to reach a specific location. Okay. Then video gaming or chess playing, for that all those are the related applications. So chess programs or AA opponents in strategy games employ goal based decisions making to achieve the victory. So video games also one of the examples. So navigation apps, most of the navigation apps also comes under goal based reflex agents. Those are, so these apps use the goal based algorithms to find the best route for you to reach your destination. So these are the few examples of the goal based. Whatever the goal is, first we are setting the goal. So how to reach the goal, and that is the important in these cases. So as you can see, goal based agents are well suited for tasks. Whatever the task is there, it is fulfilling. That requires the strategic thinking. The decision making is important. What kind of strategy? It has to reasoning is important, internal reasoning. The knowledge is important, and dynamically it has to adapt to the situation. So achievement of specific objectives in complex environments. So these are the goal-based agent reflex agents are more flexible, and it is more flexible even complex environment also it is working dynamically. It is adapting to the new situation like this. Then fourth one is the utility-based agents. This utility-based agents based on the utility function it is working. Previous all those things based on the condition first two models, and previous model is the goal based. Now it is the utility based. What is the utility? What is the utility based functions are there? Based on that the action is going on. It is same thing. It is whatever the perceptions continuously getting from the environment, the sensor sensing those things, and it is giving to the state, and it has internal state is there. Internal state it is further analyzing the things, previous condition what it is, what is the present condition. Based on that it is giving the analysis, and based on that what it will be like if do action A. If I am taking the action, what will do the action A, how happy I will be in such a state, whatever the present state of it is, or next state of it is, how happy I will be in that state. So based on the utility function, if the matching utility function it is based on that what action I do, based on the function only what action I have to do, then the actuators will do the actions on the environment. So it is the purely utility based. Here the utility function may be anything. See here, these agents are next stage in goal based counterparts. They analyze the risk, how much risk is there, and its specific outcomes, and assess the entire scenario more deeply in this system. Somewhat more deeply it is analyzing. The agents which are developed having their hand uses as building blocks are called utility based agents. These are the building blocks for the utility agent. When there are multiple possible alternatives, then to decide which one is the best, that be depending on the utility based agents, utility function, based on the utility function. They choose actions based on the preference for each state. Sometimes achieving the desired goal is not enough. It is the goal how you have to, here utility based means how to reach the goal using the utility function. So we may look for quicker, safer, cheaper trip to reach a destination. That is the main intention in this utility based. Agent happiness should be taken into considerations, because whether it is the right decision or not, if I am taking decision, so I am reaching the goal very fast or not, like this. Agent happiness is important in this case because of the uncertainty in the world. A utility agent chooses the action that maximize the expected utility. It is changing automatically. Utility function maps the state onto the real number which describes associated degree of happiness, how much degree of happiness also it is showing. So this is somewhat advanced model as compared to goal-based agents. So what are the, in these cases, the agents have some specific set of advantages are there in this case. So what are those benefits, advantages? So these AI agents are flexible and it is the adaptive. Both the things are there. It is the more flexible and the adaptability to the new kind of any kind of situation. They can incorporate agent preferences and priorities also it is considering into their decision making process. What are the agent preferences? What it is? How you have to prioritize that one and based on the decision is taking. So utility based agents can consider facts like risk, how much risk is there if I am taking like this decision A, and time is also important and effort. When evaluating different options, there is the different options. It is assessing the all the risk and the how much time it is taking, what is the cost function, all those things it is assessing. What are the limitations in these cases? The limitations in this utility based agents are designing the utility function is complex because it is based on the utility function, the decision is going on, the actuator will actuate. So evaluating the decision means here designing the utility function is most important in this case. Evaluating the utility of all possible outcomes can be computationally, it is the expensive because the more computation is going on, there is a degree of uncertainty about the outcomes sometimes. So these are the limitations, few limitations in these cases. What are the examples like this models examples are recommendation systems. So recommendation system, these systems recommended products or movie, this movie is recommended, or music to users based on the predicted utility score, how much score based on the utility score of how much the user would enjoy them. Sentiment analysis, how the sentiment, how they are feeling about the products, how they are feeling about the movies. Based on that, it is giving the ranking or numbering. It is giving. So based on that, it is recommending that this product is good or bad. Like this, it is recommending whether this movie is good or bad. There are the user rating is there based on that. The another one is the self-driving cars. Utility-based self-driving car can consider factors like safety is important, the efficiency mileage is important, and passenger comfortability is important. Comfort when making decisions, whatever the decision we are taking, it has to consider all these factors. Safety is a priority, efficiency, mileage is important, and the passenger comfortness is important. These factors it has to consider. Based on that, the utility is taking the action. Trading robots. These robots use utility functions to evaluate investment options and trading decisions based on maximizing their return of investment. Their return on investment, that is the priority it is giving. So this is the one of the example, trading robots. Trading maybe it may be anything. Suppose in the stock market, you have to get the returns, high returns. So by incorporating concept of utility, these agents exhibit more nuanced decision making capabilities. Okay, this is the utility, it is the more flexible one, more complexity also is there. Then the other model is the learning agent model. So this learning agent model is quite different. It is learning continuously and based on the situation it is adapting based on that. So learning agent is a type of agent that can learn from its past experiences, or it has learning the capabilities, it is improving continuously. It starts to act with basic knowledge and then able to act and adapt automatically through learning. It is starting with the basic knowledge, then continuously it is learning so that it is improving their skills continuously. So whatever the same thing, it is one environment, it is perceiving the environment, all the perceptions through going through the sensors, and that information is going to the performance element, what kind of action it has to do, and the same thing it is going to the critic, what it is that in the perceptions. So it is questioning itself, interrogating itself. So there is the performance standard is there based on that. The critic, based on the critic, nothing but it is giving the feedback to the learning element. It is giving the feedback to the learning element. Okay. So learning element, learning the things, whatever the changes are there, change, it is acquiring the knowledge from the learning. That is the one thing, and it is doing the based on the feedback. It is changes. It is changing the environment decisions, and it is taking the goal, learning goals, problem generator is there. So problem, what is it is generating the problem. So already you have a knowledge is there, previous history knowledge. Based on that, you can give the solution, or it can take the decisions like this. So that experiments also, it is going to the performance element through, and whatever the learning goals, it is coming to the problem generator. Based on that, it is generating the problem. Based on that, it is generating the problem, and effectors affecting that one. So here, what are the key elements, conceptual components in these cases? One is learning element, that is important. What is that? It is responsible for making improvement by learning from the environment. It is continuously, whatever the perceptions it is getting, it is learning from that. Okay. Then critic is the another important element. What it is? The learning element takes feedback from the critics. From the critics, it is taking the feedback. Okay. Feedback from the critics, which describes how well the agent is doing with respect to fixed performance standards, whatever the standards you have mentioned. Based on that standards, how it is giving the feedback to the learning element. Then learning element, it is defining the goals. What is the goal? Defining. Then it is generating the problem generator, generating related to the goal. So critic is the one of the important element in this case. Performance element, it is responsible for selecting external actions. This performance element, so based on the learning and based on the knowledge, already whatever the knowledge is there, what kind of actions it has to do. It is generating a goal and generating the problem and experiments it is. So that based on that, it is taking the action. So it is responsible for selecting the external action, what it be. So external action on the environment. The problem generator, this component is responsible for suggesting actions. What kind of action you have to do? It is giving the suggestions that will lead to new and informative experiences. Whatever the informative, and then based on the knowledge, it is giving the informative experiences. It is giving that are suggestions. Okay, this is the learning agent. It is continuously learning the things, and with it is starting initially with the basic knowledge, and slowly by learning it is improving like this, improving its skills. And what are the benefits with the learning based reflex agents? The benefits, key benefits in these cases: learning agents can adjust to new situations and environments by continuously improving their performance. It is adapting to the dynamically, it is adapting to the new environment, new situations. They can handle complex tasks also. They can, because it is learning and improving the knowledge, so that it is handling the complex tasks also. These AI agents have real world applicability, because real world solutions, these things it is giving. What are the drawbacks? And learning agents require a significant amount of data and time it needs. It needs the data for learning purpose, and the time also it needs to learning. That is the one thing drawback. The agent needs to balance exploring new options for learning with exploiting its current knowledge for good performance. Understanding how a learning agent arrived at a particular decision can be challenging, because it has to take the right decision based on the experiences. So the competition cost also, it is more in these cases. And what are the examples or applications? Few examples I have mentioned here. Personal assistants or virtual assistants like Siri or Alexa, how it is learning from the experiences. So like these are the examples for the personal assistance it is we, and a voice patterns based on the voice patterns to provide more personalized responses it is giving Siri and Alexa, like this, these are the applications tools. Spam filters, that is another way, email filtering, spam filtering. These email filters use machine learning to identify spam emails from past examples. And self-driving cars also, the automobiles rely on machine learning because it is continuously learning the things based on the present situation and previous experience. Based on that, it is taking the actions, continuously improve their ability to navigate roads and respond to changing situations. It can handle any kind of complex situations also it has handled. So the overall the learning agents are precious for various tasks. It is the more precious for various tasks it can handle, and it will pave the way for even more intelligent and autonomous systems in the future. So learning agent is the advantage. It is giving the new innovative products, innovative technologies. It is provided. And coming to the today summary, I covered the what are the types of agents I covered in this. These are the agents, simple reflex agents. I discussed description. I have briefly described about those things, and goal based, utility based, and learning based agents. All those things I have discussed in this video. And any queries, please mail me. Thank you. And next video I cover state space problem. What are their components, and different types of algorithms, uninformed search algorithms. In this breadth search algorithm, depth first search algorithm, depth bounded first search, iterated depth, all this I am going to cover in next video. Thank you.